All right, we are going to solve a logarithmic equation. So this is an equation because I have an equal sign. Okay, it also has logarithms right here, so it's a logarithmic equation. And what you have to remember when you solve a logarithmic equation,
check it.
That's right, boys, you need to check it because your logarithm has a domain restriction. Okay, the thing in these parentheses cannot be negative. Because when you go to graph a logarithm, you don't have anything back in the negative x. So your domain restriction is that whatever's in here has to be positive. So first thing I'm going to do, I am going to put these two logarithms together. Okay, I have a property that helps me with that. Let me pull it up here. Okay, this is called the logarithmic product rule. It says that if your logs have the same base, and you're adding them together, then you can make it one log to the same base, and this m and the n will be multiplied. So that's what we're going to do here. See the logs to the same base? Let's put it together as one logarithm. So we're going to have the log base 4 of, and let's multiply these two things, x plus 7 times x plus 4. All right, and this all equals 1. So now, in order to break these x's free and get them out of the logarithm, I'm going to go from logarithm to exponent. So let's look at that property. Okay, and this is the definition of a logarithm. And what you do is you're going to be able to free what's in this logarithm, this x, and you get it over here. Okay, bring it back down to earth. So what we do is we take this base b, we make it a big base b, and you can think of the other two things as switching sides. All right, let's do that here. This 4 is my base, so I want to make it a big base of 4. And the other two things are going to switch sides. My 1 is going to come over and be the exponent, and this thing's going to go over and be all by itself. So this is 4 to the power of 1 equals x plus 7 times x plus 4. All right, no more logarithm. My x's are here. I'm ready to use them. Now, we have a quadratic equation. Okay, so if you need to brush up on quadratic equations, this would be a good time. Let me write it down here. Quadratic. And first thing I'm going to do is I'm going to FOIL this out, and then I'm going to set it equal to 0. Okay, it's not currently equal to 0. So let's go ahead and FOIL it out. I have x squared plus 4x plus 7x plus 7 times 4 is 28. Okay, so this is x squared plus 11x plus 28. And that equals 4 to the first is just 4. All right, now let's set it equal to 0. I need to get rid of this 4. So I'm going to subtract 4. So I'll have 0 on the left-hand side. And I'm going to subtract 4 here. So now I have 0 equals x squared plus 11x plus 24. It equals 0. I always put my smiley face in there. Once your quadratic equals 0, then if you can factor it, you want to factor it. Okay, factoring a trinomial. If you can't factor it, we might need to use the quadratic formula. But I think this one's going to factor. It would be x and x. Okay, remember this has a leading coefficient of 1. You can go and search up videos on factoring a trinomial with leading coefficient of 1. Okay, I like to call this the easy one. That's what I call it, easy one. These two numbers back here are going to multiply to give me 24. So let's list all of our possibilities. Where did we go? There it is. So it could be 1 and 24. 2 and 12, 3 and 8, there it is, 3 and 8. 3 and 8 give me 11. All right. So it's going to be x plus 3 and x plus 8. All right, I have factored my trinomial to my quadratic equation. Now I set both of my factors equal to 0. If this factor is 0, 0 times anything is 0. Okay, so that'll be good. If this factor is 0, 0 times anything equals 0, so that'll be good. So I'll set both of my factors equal to 0. I'll do it up here. X plus 3 equals 0, and x plus 8 equals 0. Give me x equals negative 3 and x equals negative 8. Okay, now I have to check it.
Check it!
That's right, boys. Check it. Okay? If either one of these gives me a negative inside those logarithmic parentheses, then I have to throw it out. So for negative 3, let's try this. Okay, let me bring my original equation down here. All right, here's my original equation, and I'm going to substitute a negative 3 for x. So negative 3 in place of that x, and negative 3 in place of this x. Okay, this gives me the log base 4 of 4, which is perfectly fine, and the log base 4 of 1, which is also perfectly fine. Okay, if you know this, that the log base 4 of 4 is 1, and the log of 1 is 0, 1 plus 0 equals 1, 1 equals 1, and this is one of my answers, negative 3. Now, let's plug in the negative 8. All right, instead of x, I'm going to plug in negative 8 everywhere I see an x. Here's a negative 8, and here's a negative 8, okay? And I'm going from my original equation up here. Just plugging in a negative 8 there and there. So now I have the log base 4 of negative 8 plus 7 is negative 1. Okay, can't have it. Can't take the log of a negative. All right, over here, doesn't really matter, but just to show you, same thing. Log of a negative 4, can't have it. Okay, so this is not one of my answers. It's one of my possible answers, but it's not one of my answers. So the answer, the solution to this equation is x equals negative 3. Okay, now don't worry because this 3 has a negative in it, right? It's a negative 3. Don't worry about that. You can have x as a negative 3. You just can't have the log of a negative. And when I put that negative 3 into both of these, I do get positives.